Alright, in this video we're going to be talking about acceleration. By the end of it, you'll be able to describe motion of an object as it accelerates. And two, be able to calculate acceleration of an object. First, let's go over what acceleration is. Acceleration is the rate at which velocity changes. Remember, rate is just a fancy word for speed. But the big thing about acceleration is change. Okay, whether it's the change in speed or the change in direction. Velocity is a vector. Remember, it includes both. Your speed, 8 meters per second, east. Acceleration refers to increasing speed, decreasing speed, or changing direction. If any one of these three is affected, that means acceleration is affected. So let's take a look at an example of it. If we take a look here, we have a starting of a marble at the top. That marble then goes over and starts rolling down a hill. If you take a look, our A, acceleration, is pointing in the same direction as our velocity, V. That's because we're heading both in the same direction and they're both increasing in speed. The same speed. However, when they get to the flat, our velocity is still pointing east. It still has the same direction, but our acceleration is pointing backwards. That's because the marble starts to slow down. It accelerates, gets to the flat, slows down, therefore acceleration is pointing backwards. Once we start going around a curve, now we're changing direction. Our velocity and acceleration are in the same direction. The same arrow's pointing, right? Because now we have a change in direction, therefore we're accelerating. Once we've completed that turn, come back to a flat, our velocity is then pointing west, but our acceleration is pointing back because now we know that the marble is slowing down again. Again, those flats mean slowing down. Let's take a closer look at this. What I mean about slowing down and speeding up. Acceleration can be referred to as positive or negative. Positive acceleration is what you feel when you're in the car and your mom or dad, guardian, hit the gas pedal and you go, right? That's accelerating. You're going forward. Same as the marble at the top here. Once it starts to roll down the hill, it has a positive acceleration. You're on your bicycle, you start going down that hill, you really feel yourself starting to speed up. When that hill ends that you're on your bicycle with, you get to a flat, you know that you start to slow down. Okay, your acceleration is in a negative. Once you get to going around a curve here, now you're changing your direction, you're in a positive acceleration because the change in direction is increasing the speed here. So you have a positive acceleration. Then once you get into a flat again, your acceleration is going down, therefore you have a negative acceleration. Positive acceleration speeding up, negative acceleration slowing down, positive acceleration going around a turn, changing direction, negative acceleration slowing down. Let's take a look at how we calculate acceleration. Acceleration equals final velocity minus initial velocity divided by time. If we were looking at that same marble problem, at the top, when the marble is just sitting at the top of the hill, it has a speed of 0 meters per second. When it starts rolling down, it's got its direction. It now has a speed and direction of 6 meters per second. It took 3 seconds to get to the bottom. Let's see where it fits up in the formula. We have our final velocity, the end point of 6 meters per second. That's what goes in the first spot. Subtracting our initial velocity of 0 meters per second over here in the second spot. All that is divided by time. The time that it took from the start to the finish It's 3 seconds. So our acceleration equals 2 meters per second squared. You need to make sure that you're paying attention. Acceleration is measured in meters per second squared, our SI unit. Don't forget that little squared part, when we're talking about acceleration, needs to be included as your unit. That's it.